up from the ground, situation 2. Again, you have your 9 variables to consider, diagram as shown. Standard known values should be listed multiple times by now. Remember that these are not linked problems. So, in situation 2, you are given the total time, meaning this object is in the air for this amount of time. You can find two things, height and velocity. So let's get started with an example. A cannon is shot straight up and has a total air time of 3.4 seconds. How high did it go and what velocity was it thrown at? Well, remember that the total time was what was given of 3.4 seconds. That means that time up is half of that, which is 1.7 seconds, and time down is the same thing. Once you have that, you can find, always remember the velocity at the top is equal to 0. You can find height, how high does it go, which should be 0.5 times a negative 9.8 times that 1.7 squared. Grab your handy dandy calculator. 0.5 times a negative 9.8 times 1.7 squared is 14.161 meters. Now, when I plug that into my calculator, I get a negative value, but remember, because it's coming down, we're looking at height, which will be positive, because it's going up at some point. Yeah, okay. Anyway, so how high does it go? Matching to our question should be 14.161 meters. Then we can find velocity at the bottom. Now, velocity at the bottom will be a negative 9.8 times that time down, right? 1.7. And that will be a negative 9.8 times 1.7, which should be a negative 16.66 meters per second. Now, that's the velocity at the bottom, okay? So that means that the velocity, the initial velocity, would be a positive 16.66 meters per second. And that's the velocity that we actually want in our question, meaning what velocity was it thrown at is going to be that positive 16.66 meters per second. All right, so this was situation 2, up from the ground, given the total air time.